Today we're going to look at two examples of writing and then solving one-step equations. One we'll look at for subtraction and one we'll look at for division. So the first one is going to end up involving subtraction. So the word problem is, Mike has an unknown amount of money in the bank. Then he withdrew, which means takes out, $20. Now he has $58 in the bank. Write an expression that represents this scenario and solve it to find how much money Mike started with. Okay, so let's try to get the equation. So if Mike had an unknown amount of money in the bank, that's going to be my variable. That's going to be x, or any other variable I want to come up with. Right, I don't know that amount. So that's how much Mike started with. Then he withdrew $20. Right, so if you're withdrawing, take $20, you're taking away $20. So I have an unknown amount of value, x, and then I'm subtracting 20. I'm withdrawing that 20. And then I'm told, now, after I've withdrawn that $20, Mike has $58 left in the bank. So that's his current total. So when I have my starting amount minus my $20, I end up with $58. So my equation x minus 20 equals 50. As a note, with one-step equations, you might be able to figure this out without writing the equation. But that's not our goal right now. Being able to write and solve an equation is going to set us up for even harder problems that you couldn't do in your head or without writing an equation. So this process is super important, not just the answer. Okay, so we're going to look at two ways to do it. One is with this flow chart, which really looks at the process of how do we undo, or how do we take the inverse of whatever's going on in our equation. So our equation here, I'm going to write it in the middle, is x minus 20 equals 58. And then the flow chart is saying, okay, so I start with x. What happens to my x? Well, I can see right here, I subtracted 20. Guys, so that's what I'm going to write there. I started with x, I've subtracted 20, and then that led to giving me $58. So that's just kind of thinking about what's going on in the problem. Now I need to undo that process to figure out what x is. So I have $58. Working backwards, I need to undo subtracting 20. In other words, what's the inverse operation of subtracting 20? Well, the inverse of subtracting is adding. So to undo subtracting $20, I'm going to add $20. Right, I'm going to add 20. And thus, that's going to end up giving me my answer. If I take 58, I add 20, that's going to give me what x is, which will be 58 plus 20, which is 78. So that tells me x equals 78. So that would mean that Mike started with $78, which is correct, right? And that's one way to do it. It's not kind of the end goal, but it's a way to make us understand what we're doing when we're solving these equations. Let's see what that looks like over here, which is kind of the more traditional way to write out these problems, and it's going to set us up for harder problems down the line. So I'm going to rewrite my equation. X minus 20 equals 58. Okay? And then I want to make this x all by itself. So if I want to get x by itself, currently I have x minus 20. For x by itself, I need to undo or take the inverse of that subtracting 20. So, like our flowchart told us, right, the opposite, or the undoing process, the inverse of subtracting 20 is adding 20. So I'm going to have x minus 20 and then plus 20. And then what our entire concept for this balancing equations method, right, is for equal signs. If I do something on one side of the equal sign, I absolutely have to do it to the other. Otherwise, if I only do it to one side, I'm not creating a balanced equation. It doesn't stay the same. So then on this side, I had 58, and I'm going to have to add 20 as well, just like I did there. If I add 20 on the left, I add 20 on the right. All right, so this is what we'd see. We have x minus 20 plus 20. Well, probably we can get in our heads that if you subtract 20 and you add 20, you're getting 0. That's going away. But if that's not clear, we can do what we've been doing all along, which is we can think of this subtracting 20 as adding a negative 20. Okay, so this is adding negative 20. Negative 20 plus 20, that is 0. So we have x plus 0 equals 58 plus 20, which is 78. and then taking x plus anything, 0 plus anything is just what we started with. So x plus 0 is just equal to x. So we get x equals 78. Right, so again, that would be saying that Mike started with $78 in his bank account. Alright, and in this example, we're going to look at one involving division. So again, before I read the word problem, I want to remember that our goal for this isn't really just to get the right answer. Our goal is to write an equation and solve the equation. Because there are lots of ways to get this answer, to get answers like this without you solving an equation. That's generally going to be the case for one-step equations. But as you're going to see, we're going to get to harder and harder equations this year and in 8th grade and in high school. So what we're doing now is building the foundation for how you solve equations. Alright, so the question is, Alyssa has a lot of pencils to distribute evenly to her friends. She gives each of her friends 7 pencils, and she has 6 friends. Write a division equation to represent this situation and use it to solve for the number of pencils Alyssa started with. So that number of pencils that Alyssa started with, right, that's going to be our x. That's what we're trying to solve for. That's our variable. So Alyssa starts with a certain number of pencils. Then she wants to distribute them evenly to her friends. That's going to tell us we're going to divide. If we're distributing something evenly or splitting it up evenly, that's a sign for division. So she's going to distribute them evenly to her friends. She gives each of her friends 7 pencils, and she has 6 friends. Alright, so we got to figure out the order for that. If I have a certain number of pencils, that's what I'm going to start with, x. Okay? And then if I'm dividing it into 6 groups, right? If I have 6 friends, I'm dividing that amount of pencils I have into 6 different groups. So that's what I'm going to divide. I'm going to do x, the number of pencils that I started with, divided by 6, which I'll normally write as a fraction. That's how you'll see it. X divided by 6, and that gives me 7. Once I take the number that Alyssa started with, I divide by 6, the number of people that there are. Each person gets 7 pencils. So that's my equation. X divided by 6 equals 7. And like before, we're going to solve it using the flowchart method and using the more traditional balancing equations method. This flowchart method is going to make us understand what we're doing, and it's going to help us when we're doing this process. Okay, so if I look at this, the idea is I started with an x, and that's what I'm trying to figure out. What is that x? So I started with an x, and then what did I do to the x? Well, I divided it by 6, right? So I had my x, and I divided it by 6, and then that gave me 7, right? So that's just representing the problem. Now I need to go backwards, and I need to undo that process using inverse operations. So I have 7. To figure out x, I need to do the undoing process of dividing by 6. So how do I undo dividing by 6? What's the inverse operation of dividing by 6? That's going to be multiplying by 6. Right, I'm going to multiply by 6. So I have 7, I multiply by 6, and that's going to give me an answer. That's going to give me x. 7 times 6 is 42. So this tells me that x equals 42, which would be pencils here. So Alyssa started with 42 pencils. So now let's see what that looks like over here. I have my expression, x divided by 6 equals 7. Okay, so I'm dividing by 6. I want to do the opposite of that. I want to undo it. So to undo dividing by 6, I'm going to multiply by 6, just like my flowchart told me. Okay, so if I multiply by 6 over here, I have x divided by 6 times 6. I also need to do that on the other side of the equation. If I'm doing something to one side of the equation, I have to do it to the other. Otherwise, I'm not keeping it a balanced equation, a true equation. Okay? So I multiply by 6 over here, and I multiply by 6 over here. Now I have x divided by 6 times 6. So that's just equal to x. Right? So this is saying x divided by 6 times 6, dividing by 6 and multiplying by 6, those undo each other. So we're just left with the x we started with. And then we can see that out because dividing by 6 and multiplying by 6, that really just gives us 1x. And 1 times x is the same thing as x. So either way, we get x equals 42 or x equals 42 pencils.